So we know that you have new bone tissue building in the middle, and then the old tissue gets pushed out to the edge, and that this is a continual process. You have to get rid of that old tissue at some point, or your bones are just going to keep getting bigger your whole life. So now we can look at the osteoclast. The osteoclast are the cells that dissolve old bone tissue. And they are made by fusing bone marrow cells. So you have several bone marrow cells fused together. So that you get this one big cell. So this whole thing right here is the osteoclast. And you can see it's really big. And I tend to abbreviate osteoclast as OC. So osteoblast is OB that builds bones. Osteoclast is OC that dissolves bones. And notice it has all these kind of like tentacles that hang down. It looks kind of like a jellyfish. All these tentacles here that hang down are called the ruffled border. And the purpose of this is to create more surface area. And this ruffled border secretes hydrochloric acid. And that hydrochloric acid dissolves the bone. And when you dissolve bone, the nutrients are returned to the blood. So remember the osteoblast were taking nutrients from the blood to make the bone? Well, now when the osteoclasts dissolve it, those nutrients go back to the blood. So you're recycling this bone tissue. And the one we're especially concerned with is calcium. So every time your osteoclasts dissolve your bone, they raise your blood calcium level by taking calcium from the bones and putting into your blood. So one of the main ideas here is that osteoclast increase blood calcium level. So now let's start to put some things together and kind of see a bigger, complete picture. So we know you have your bones are being remodeled. You're making new tissue, you're getting rid of old tissue. So on this side here, on the left, we have your osteoblast, which we know are what build the new tissue. They are controlled by the osteocytes. So here is our osteocyte. The osteocyte, remember it's the retired osteoblast, its job is to monitor the stress on your bones. Well, stress on bones comes in the form of exercise. So here's Donald Duck lifting weights. When he's lifting weights, that stresses the bone. Stress makes you stronger. So every time you stress your bones, the osteocytes detect this, so they will detect when you exercise. And they will stimulate your osteoblast to build more bone. And when they build more bone, your bones get stronger and denser. And you do this by taking calcium from your blood. So this has the effect of reducing your blood calcium. Then on the other side, we have the action of the osteoclast. Osteoclasts are controlled by hormones. So you have here in your neck the thyroid gland and the parathyroid glands. So the big part here is the thyroid gland. It's this butterfly-shaped gland in the neck. And its main job is to control your metabolism, but it also monitors your calcium. Then embedded inside of it, these little dots here, that is the parathyroid. So both of these glands monitor your blood calcium level. The thyroid gland responds if calcium is high. So if you have high blood calcium, then this gland secretes calcitonin. The parathyroid responds when blood calcium is low. Okay, so whenever blood calcium is high, the thyroid responds and secretes calcitonin. Whenever blood calcium is low, the parathyroid responds and secretes PTH. Now, I have to put an asterisk here by this, though. Calcitonin is mainly only effective in children, and we don't know why. Science has not figured this out, but we know that this only works in children. Adults are pretty much just running on PTH. Okay, so we'll go ahead and we'll look at what calcitonin and PTH do, but just keep in mind that this stuff about calcitonin applies to children. Okay, so these hormones are going to control the action of the osteoclast. So here is your osteoclast, and remember it is dissolving the bone. And raises blood calcium. Okay, if blood calcium is already high, you don't need to add more calcium to the blood. So calcitonin is going to inhibit your osteoclast. It's going to tell them, hey, take the day off. We have plenty of calcium in the blood already. We don't need you adding more. PTH has a synergistic partner. Sometimes hormones work in partners. Think of this like Batman and Robin. Right? They work together to fight crime. So PTH is going to get its synergistic partner, which is calcitriol. So if blood calcium is low, your parathyroid gland secretes PTH. PTH goes to the kidney and says, hey, come on, calcitriol, we got to go raise blood calcium. Then the two of them are like Batman and Robin, and they go out to raise blood calcium. Remember, osteoclasts are what put calcium in your blood. So they are going to stimulate the osteoclasts to work more. So let's put all this together. Here is your bone. On the one hand, in response to exercise, you have osteoblast build bone tissue. This makes your bones stronger. And it reduces your blood calcium because you're taking calcium from the blood to put into the bones. On the other side, you have your osteoclast dissolve your bone. This is controlled by hormones that tell them if they should work more or work less based on what your blood calcium is. So let's look at some scenarios. Let's look at scenario one. Let's say we have somebody who, it's break from school, like you've got a month off from school or something, and you spend that month, you just lay on the couch and watch TV, and you have a lot of Dr. Pepper and tacos. Okay, if you're laying on the couch, you're not exercising. So this means that your osteoblasts are not being stimulated to build bone tissue. And if you're eating a lot of tacos and Dr. Pepper, that's not putting calcium into your blood. That's a low calcium diet. So you're going to have low blood calcium, which is going to cause you to use PTH and calcitriol. And you're going to dissolve your bones more. So the net effect of this is that you're not building new tissue and you are dissolving your own tissue. So you are going to have a net loss of bone tissue. So your bones are going to get weaker during that month you spend laying on the couch drinking Dr. Pepper and eating tacos. Okay, let's look at what else you could do with your month. Maybe you go to the gym and you exercise. And you decide you're going to be healthy and you eat lots of yogurt and broccoli. Okay, so exercise is going to stimulate your osteoblasts to build bone. And the yogurt and broccoli is going to put plenty of calcium into your blood. So you're going to have calcium from your diet. Now, in an adult, this doesn't necessarily mean you're going to get a lot of calcitriol. What it means is that you will have it doesn't necessarily mean you'll get a lot of calcitonin. That's in children. This means you will have low PTH and calcitriol. You'll just turn down your PTH. So you will do less stimulating of your osteoclast. And the net effect of this is you're going to have a net gain in your bone tissue, or at least not lose bone tissue, depending on some other variables going on. Hormones, estrogen plays a big role in this, your age plays a big role in this, so there's other factors. But you will at least avoid making your bones weaker. Okay, so we've been talking about putting calcium in the blood. Let's look at why you need that. There are 4 main reasons why you need blood calcium. Your heart relies on calcium in order to beat. And we will cover this quite a bit in chapter 19, but in order for your heart to beat, it has to have access to calcium from your blood. Your neurons use calcium to secrete neurotransmitter. And we will learn about this in chapter 12 when we talk about neurons. But in order for your nervous system to work and secrete its neurotransmitter, it has to have access to calcium from your blood. Your muscles need calcium in order to contract. And this we will learn in chapter 10, how muscles use calcium to contract. And finally, your blood needs calcium in order to clot. Like when you get a cut and you're bleeding and you stop bleeding, that's because you made a blood clot. You have to have calcium in order to make blood clots. So again, it's kind of redundant, but just to make sure you understand the importance of this, you have to maintain homeostasis of blood calcium. So right here, 8.9 to 10.1 milligrams per deciliter. That is your homeostasis for blood calcium. That's the amount of calcium that has to be in your blood in order for your heart to beat, your neurons to secrete neurotransmitter, your muscles to contract, and your blood to clot. So calcium can only be one of 2 places. It's either in your bones or it's in your blood. If it's not in one, then it's in the other. Think of your bones as like your bank account, and think of the blood as like your wallet. Let's say every day you get up and you come to school and you want to make sure you have about $9 or $10 in your wallet. That way you can buy lunch and you can get a drink from the vending machine and you can make it through the day. So every day, if you have less than $8.9 in your wallet, then you go to the bank and you get some money out. If you find that you have more than $10.1 in your wallet, well, you don't want to walk around with all that extra money, so you go to the bank and you deposit some money in there. You're constantly going back and forth to the bank to make sure that you always have about $9 or $10 in your wallet, because that's what you need to get through the day. So that's how it is with your bones and your blood. The calcium is either in one or it's in the other. So when you have extra in your blood, you move it into your bones. If you don't have enough in your blood, you move it out of your bones. So we know that the osteoblast will build bone, and they are what move the calcium from blood to bone. So from your wallet into your savings account. And we know that the osteoclasts are how you withdraw that calcium. So osteoclasts dissolve bone to move calcium from bone, which is your savings account, to blood, your wallet, the calcium you're using. The main way this is controlled is through PTH. PTH is your main method of control. It's pretty much in charge of how much calcium goes back and forth between your blood and your bones. And again, this is talking about an adult. So kids would have calcitonin, but we're going to focus on what happens in adults, so we're not even going to mess with calcitonin. We're just going to talk about PTH. So if your blood calcium is low, then you will have more PTH. The lower your blood calcium, the more PTH you need. That extra PTH will stimulate your osteoclast to dissolve more bone. So your osteoclast will work harder and they will dissolve more bone. This will then raise your blood calcium. If blood calcium is high, if you're doing good and you have plenty of calcium in your blood, then you just have less PTH. You turn down the PTH. And when you have less PTH, then you're not telling your osteoclast to work. So they get kind of lazy. They hang around, they take long breaks. They're not really doing much. So in the absence of that stimulating PTH, your osteoclasts just kind of take it easy. So in an adult, that's the basics of what's going on. You just adjust your amount of PTH. If you need more calcium in the blood, you get more PTH, so you dissolve more bone. If you need less calcium in the blood, then you have less PTH and your osteoclasts just kind of take it easy.